This is a series of videos for people who want to learn Linux but don't have a lot of time. I make a couple of basic assumptions. First, you should know what a partition is and what a partition table is on a hard drive. Second, this is also going to be very informationally dense. You'll probably want to pause a lot, rewind a lot, and I would suggest that you watch each video through in its entirety before you go back and try anything that you saw. We'll go ahead and jump in feet first. I'll assume that you've downloaded the ISO image and that you have VirtualBox ready to go. Once you've downloaded the disk image from their website and then burn it to a disk, or even if you're just installing from the ISO, the first screen that you'll see after the reboot is this installation screen. Go ahead and choose your language and then hit Install Ubuntu Server. I obviously chose English. And it's going to bring up this installation menu next. Keep installing English, United States, or whatever the choice is that you need. And then it's going to ask you to pick your keyboard layout. Most people are going to want to not auto-detect. The auto-detect asks a series of characters that match on your keyboard, and it takes a really long time, and almost everyone has the same type of keyboard now. After the keyboard select, it goes through an initial package retrieve, which I've sped up for you, and then it plops you into the next screen where it attempts to pick an IP address off of a DHCP server. For this installation, I'm assuming that you have a DHCP server. If you don't, you can always go and set up your own IP address. Put in a host name that you like for the machine. This is kind of a religious battle for a lot of admins. Just pick a host name that you like for now. We're going to be replacing it later anyway when we do the reinstall on the quote real server. Pick a full name for a first user. This is a non-admin account, but it is going to be the user that you use for the rest of the time. Pick a decent password. It doesn't have to be great for this. I used ASDF, which is why it's asking me if I want to use a weak password. I'm fine with that in this case. I do not want to encrypt my home directory. It doesn't make any sense for this. And in general, I'm not really sure that you want that to be on a server in the first place. Pick your time zone. In this case, I am correctly in New York. It'll probably auto-detect incorrectly for you if you're not East Coast. I've had that happen a lot. Then finally, we hit disk partitioning, which is something that's actually kind of interesting. My assumption here is that you know how to partition a disk, or at least what disk partitions are. So I'm going to go through the differences in how Ubuntu handles disk partitioning. Here we definitely want to do the manual process. Once you go down and select your drive, in this case the first SCSI drive, SDA, when you hit enter, it's going to create a new partition table, assuming that the old partition table is blank, which is the situation that you should be in. A friendly word of caution: if you do select a disk that has data on it, it's going to wipe your partition table. You probably don't want to do that if you value the data, so make sure that you're actually writing to a blank partition table on a blank disk. And once we've created the blank partition table, let's take a second to really stop and think about partitioning. How it pertains to Linux is probably different than what you're used to, especially if you've never used a Unix system before. It's very different from the world where you have, say, a C: drive or a D: drive, and those represent partitions on a hard disk. Even in the Windows world, you don't have access to the entire disk in a partition. It's apportioned off in some way, and then those become a C drive or a D drive. In Linux, you have a single master view of the file system. And so instead of having to switch between drive letters, which is the traditional Windows way of handling things, the Linux system has a single directory structure that starts with a slash. And then underneath of that, you can add partitions into the file structure, but it's all seamless. There are two main reasons for doing this. The first is that it's very convenient. You no longer have to worry about what partition your data is stored on necessarily. The users of the computer don't have to be in any way familiar with how the drives are laid out in the system in order to use it. For a lot of people, this could be a really foreign concept, so I think the best thing to do is just run through an installation example. We'll revisit this later in the video series. Go down into the area of your new drive where it says free space, hit enter, and then create a new partition. For this initial run, we're going to set a first partition size of 15 gigs, which is a 15G, then hit continue, make it a primary, and put it at the beginning of the drive. Now we have some options as to what to actually do with it. This is the dialog to set up a file system. The only thing that I really want to change here is to make it bootable. Everything else we can explore later. Time to make another one. This time we're going to make a swap partition. Windows users are probably familiar with the system page file. Swap partitions are effectively the same thing. It's a place where the operating system can store uh, memory that isn't needed to be resident in RAM. Lastly, I want to set up a partition just to store files and user information. One technique that you might find useful is to separate your operating system from your user data. Then later, if you need to format the operating system and reinstall, you don't lose all of your personal files and settings. The astute viewer will see that I've picked XFS this time instead of extended 4. I did this simply to show that XFS, which is a file system, can be used at the same time, or more specifically, that Linux can use multiple file systems simultaneously. So instead of only having the option of NTFS or VFAT, you can pick any combination of file systems that do exactly what you need. So in this whirlwind of partitioning, we've made 3 partitions. The first is extended 4, and it's going to be the root partition, the slash partition that I alluded to earlier. The second is a swap partition, and that's going to store temporary information that's been pulled from RAM to disk so that it's not constantly memory resident. And the third is an XFS partition that's going to be used for the home directories. The home directories are specifically designed for users to store their data and their configuration settings. You separate them out so that in the event that you need to format the server or reinstall Linux for whatever reason, or if a careless user fills their home directory, the operating system and the files that are maintained on the system are separate. So if at this point you're happy with how these partitions look, select yes. It's going to erase your drives, reformat them with everything that we need to move forward with this Linux installation. As soon as the formats are complete, the installer starts pulling in packages from the CD image. I've sped this up significantly because in real time this actually takes quite a while, but I thought that it would be extremely boring. Frequently during these videos, when we run into something that is going to take a long time, I'll speed it up as fast as I can through the screen recording software. But sometimes you're just stuck listening. In this case, you've got about 20 seconds left to go. Halfway through this installation, you'll get asked if you want to do automatic updates or if you want to install any particular packages. We want to do everything by hand so that we learn the most, so just turn off automatic updates and don't install any additional packages. Now we need to discuss something called a bootloader. Bootloaders are programs, very small ones, that are installed by operating systems onto your hard drive. And the premise is that when your computer boots, it checks on the drive in a special area called the boot sector to see what it should do to load as its operating system. And since it would be impossible to put the entire operating system, which are often multiple megabytes, even compressed, into that portion of the drive, it uses a small bit of code that tells the BIOS how to load the actual operating system. The Ubuntu installer is going to install a bootloader called Grub, which was originally written for the GNU Herd project, but has since been used for Linux and all sorts of other, even BSDs and Windows installations, as a multi-boot manager. So you probably just want to hit yes to the install Grub prompt. It'll run through, put it on your first hard drive, and then continue on with the installation. And that's it. You're going to be presented with a dialog that gives you a continue or go back button. Continue is going to reboot the computer. Go ahead and do that now, and it's going to come back up into your first Linux boot. Congratulations! The first thing that you'll see after the reboot is this, the bootloader menu, and then it will immediately go into a bunch of text. This is kernel debug log messages from the boot up itself, and this is also perfectly normal. The output might look ugly now, but at some point you're going to be really thankful for it. Our first quick task is to start exploring the file system itself. The reason that you do this first is because in Linux, every configuration file and actually every device, pretty much anything that you would need to access is represented by a file somewhere on the file system. And the file system hierarchy itself is an excellent starting point so that you can understand how the system differs from what you've used in the past. The first thing is that by convention, files and directories are separated out from the root directory based on their function. So configuration files are stored in one subdirectory of root, user files are stored in a different one, binaries are stored in a different one, and highly variable data is stored in yet another one. Understanding how all these different locations work together and where things are stored is critical. So the first thing that we want to do once we log into our new machine is explore this a little bit farther. At the login screen, go ahead and log in as the user you created during the installation. In my case, I created a username student and gave it a password of ASDF. A couple of quick things happen. The most important is that it dumps you into what's called your home directory, which in this case is /home/student. Your home directory is where all of your personal configuration settings and files are stored. Since I don't have anything there yet, I want to check out what's in the slash directory. So I do cd/, and then I use something called the tree command to just quickly display the subdirectories in there. I'll go through and explain on the screen what the different subdirectories do. We'll be exploring these much more in depth later, but at this point it's probably more efficient for me to explain in text than to explain in voice what each of these directories do. The notable exception perhaps being etc., which stores configuration files that are global. So any type of services that we configure later will be going into there. The next directories, /media, /mount, and then later /lib, are purely informational. You'll use them occasionally, but they're not necessarily critically important for what we're doing now. Eventually you'll want to know what's there, but for now, just the fact that you know about them is good enough. To introduce our first critical command is ls, which is short for list. And ls simply shows the files and directories that are in the directory you're currently working in. If you run ls by itself, it shows you the current directory. ls-l shows you more detailed information about the directory that you're looking at. So in this case, for instance, we have in the first column file permissions, which we'll go over much more later, owner and group, the modified date, and the directory name are the quick at-a-glance information here. Another important thing to remember is that pretty much any application program in Linux that works on files or directories can be given a direct path. So in this case, I wanted to do a long listing of what was in /home. And instead of having to cd to /home and then do it with an ls, I can just feed /home to ls. ls is a program, and a lot of other programs are stored in /bin. In the interest of exploring, something that you'll probably want to do is check out on your own all the different applications that are in /bin. There are some pretty interesting ones just on screen now that you can see are things like I saw sed scroll by, netstat, makedir. These are all commands that you'll want to master, as you'll be using them pretty much every day. One great feature of the command interpreter that we're using, which is called bash, is something called file globbing. And if you do something like an ls-l star, it will list all of the files or directories that start with an L in the current directory. You see here in this listing the echo program, which I'm going to use to demonstrate something called the binary path. The path is a system variable that's set per user, and it is all of the directories that the shell will search for a program that you want to run if you run a program without using the complete path name. So I've run echo in two ways. The first is just by doing echo yes, and the second is with the /. The /, as I'll explain in a second, references the local directory. Anywhere that I go, I can run just echo by itself, but if I go somewhere and run .echo and there's no echo binary in that current location, then it won't run because that file doesn't actually exist. With that mini lesson out of the way, let's look at a little bit more at the file system. The first is /home, which only has /student. The next is /var. var is designed to hold variable data. Some examples include log files and mail spools, like email spools. They also include things that are transient in nature, like a certain type of control file called a PID file, PID file, or temporary files, or even cache files. And perhaps most commonly, var lib MySQL will eventually hold your MySQL databases. And then next up is /user. And there are two notable things to /user. First are /userbin and /usersbin, which hold additional system binaries, and /user/local, which is traditionally where a lot of people would put their locally installed programs. So if you compile something outside of the package management system and you need to put it somewhere, user local is a good target. With all of that quickly out of the way, there's only two more things that I want to explain in this introductory chapter. There are two pseudo directories, which they're not actual directories, but in every directory on the system there's going to be a .. and a directory. The directory always refers to the current directory that you're in, and the directory always refers to the directory that is one layer up the tree. The next to last thing that I want to mention is that there are some files and directories that you will not have permission to as the student user. In this case, /root is off limits. We'll explore why that is later, but for now, when you encounter a permission denied error, it typically means that you have done something as a non-root user that you need to be root as. So you can use the sudo command, like I'm about to do here, to turn the machine off, to override those kind of limitations. we'll be using it pretty frequently as we go forward. So let's recap real quick. We can shut down the server. We can explore the file system a little bit, and hopefully you have just a cursory understanding of what's going on in the file system. We'll definitely explore this further, including the next lesson, which is on basic commands. Some of basic commands is going to be a repeat from this. Anything that's repeated is typically done so because it's fairly important to know. It could also be, of course, due to my lack of planning, but I'm going to hope that's not the case very often.